This final review video for test number 2, this part 4 is going to be the last few problems about solving absolute value equations and then about absolute value transformations with the parent function. All right, so take a look. Okay, so let's start here by solving these absolute value equations. So this one we have -4 plus 9 times the absolute value of 7x minus 9 equals 14. All right, we need to work this out to where all we have left is the absolute value. Okay, so let's go ahead and start by adding 4 to both sides. So that would leave us with 9 times 7, or the absolute value of 7x minus 9 equals 18. Now we can divide by 9 on the left side, so we can also divide by 9 on the right. And now we have the absolute value of 7x minus 9 equals 2. So now we can set it up as 7x minus 9 equals positive 2, and our 7x minus 9 equals negative 2. Okay, when we work this out, we are going to add 9 to both sides. And we get 7x equals 11. And then we divide both sides by 7. And we get x equals 11 over 7. Okay. On the right side, if we add 9 to both sides, we get 7x equals 7. And then we divide by 7, we get x equals 1. Okay, let's move on to this next one. All right, this one may look a little bit different because we have both the absolute value on both sides of the equation, but we have x plus 2 equals, or the absolute value of x plus 2 equals the absolute value of 3 minus x. In order to solve this, because it's absolute value, we're going to set x plus 2 equal to 3 minus x, and we're going to set x plus 2 equal to negative 3 plus x. Again, we did the negative, or we negated this answer. 3 times negative 1 is negative 3. 3 times negative x is positive x. Or I'm sorry. We multiply both of these terms times negative 1. Okay. So I'm going to subtract 2 from both sides in order to solve this. And I'm going to end up with x equals 1 minus x. Then I'm going to need to add x to the right side and the left side, and I get 2x equals 1, and then I divide by 2, and x equals 1/2 is one of my solutions. And then over here on this side, again, I need to get my x's together and my constants together, so I could start by subtracting 2 from both sides. When I do that, my equation would say x equals negative 5 plus x. Then I'm going to get my x's together by subtracting x on the right side and then on the left side. But I'm going to end up with 0x equals negative 5. And obviously when you have 0x, there's no solution, or we could call that undefined. Okay? All right, moving along. This last one here, as far as the absolute value equations. Same thing, we have x plus 3 equal to x minus 11. So we're going to set x plus 3 equal to x minus 11. And then we're also going to set x plus 3 equal to negative x plus 11. In order to do that, we're subtracting 3 from both sides. You may have a different way of doing that, but x equals x minus 14. And then we would subtract x from both sides. And again, over here, you end up with 0x equals negative 14. And we cannot divide by 0. That would be undefined. Or we could say no solution, okay? All right, working over here on this one, I would need to subtract 3 from both sides, and my equation would be x equals negative x plus 8. And then I would add x to both sides, and I would get 2x equals 8. And then I could divide by 2 to solve for x, and x equals 4. okay? We could check that if you wanted to, but 4 plus 3 is 7, and the absolute value of 7 is 7. And over here, 4 minus 11 is negative 7, but the absolute value of negative 7 is 7. So that one checks out. All right, let's move on to this last section in the review, okay? This says to describe the transformation from the equation and state the vertex, okay? So this is our absolute value function, okay? But here it is in vertex form, okay? Remember, inside the parentheses is going to shift the function or the vertex right or left, okay? A minus 2 would actually shift it to the right 2 units because it's always the opposite of what's inside the parentheses or the absolute value. And the plus 3, the number on the outside shifts it up or down, and it does exactly what you would think. Positive shift up, negatives would shift down. So to describe this transformation, we understand that x minus 2, the minus 2 actually shifts it horizontally, or we could say shifts to the right 2 units. Shifts to the right 2 units, or maybe horizontally 2 units. And then we understand because of the plus 3 that it shifts vertically, or we could say shifts up 3 units. Probably should say vertically, but shifts up 3 units, okay? The new vertex then is the HK, or it is this is the new, the X value we're gonna add 2. So 0 plus 2 would be 2. And then the Y value, if it was originally 0, 0 at the vertex, and we add 3, 0 plus 3 is 3. So that is our new vertex, 2, 3. It's always the opposite of what you see in here, so plus 2, and then this exact number, 3, that would be the new vertex. Okay? All right, let's go over to this graph here. So this says to write the equation to the graph using the function below, okay? So this is our absolute value function. You'll notice that the vertex is here, okay, but it's still over 1, up 1, over 2, up 2, over 3, up 3. So it hasn't shifted. It hasn't had a vertical stretch or a horizontal stretch, okay, but it has shifted over and up, okay? Well, here's the new vertex, okay? So if we highlight the new vertex here, okay, we understand that the ordered pair there is at 4, 5. The x is 4 and the y is 5. So if we want to consider the function, we would say f of x equals the absolute value of x minus 4, because it shifted to the right 4 units, and on the outside it shifted up 5 units, so we would have a plus 5. That would be your function or your equation for that function, okay? Now let's take a look at this question here. This says to write the equation that represents the following transformation. The absolute value function is vertically stretched by a factor of 5, horizontally shifted right by 3 units, and vertically shifted down by 2 units, okay? So the first thing to consider is the vertical stretch of 5. Remember that the vertical stretch is the number in front of the absolute value, okay? So this 5, this vertical stretch of 5, it's going to make it skinnier, okay, by a factor of 5. And then horizontally, it shifts right 3 units. Well, how do you shift something right 3 units? You would actually do x minus 3, okay? And then finally, it's a vertical shift down by 2 units. That means we have a minus 2, and that would be your function, all right? Or the equation that represents that transformation. Okay, last one. Okay, this one has a point at 5, 3, okay? That's on f of x. What will the coordinate be after applying the following transformation? So this is the transformation, okay? This is actually written in in our vertex form. So remember, inside the parentheses shifts it right or left. Outside the parentheses shifts it up or down over here. And normally we start with the vertex, but what we have in this problem is that we're starting with 5, 3. Well, we're just going to apply this transformation. X minus 4 means it shifts it to the right 4 units. So our X value, we're going to add 4 units to it. Okay? And what is 5 plus 4? Well, it's 9. So our new X value is going to be 9. What about the Y value? Well, in this transformation, we have a plus 3. That means we're going to add 3 units, or add 3 to the Y value. So here's a 3, and of course, if we add 3 to that, we get 6. 6. So that would be our new point. Okay? The last part of the review to consider is this page. You should be somewhat familiar with it. You need to know all of these functions, okay? You have some notes from that in Canvas if you need it. On the test, though, you're not actually going to have to write the function and draw the graph. You're just going to need to recognize which graph is which and kind of match them, okay? But that will be part of the test as well. All right, so that's the end of the review. I hope if you have watched some of these videos or all of them that it has been helpful.